Children, a very good morning to all of you. See, in the previous class I discussed, what I was discussing in the previous class? I was discussing how to find the quadratic polynomial when its sum of zeros and product of zeros are given. This was our last discussion, okay? Now, I had also told in that class, the last part of this chapter, that means, suppose you are given any degree polynomial, Suppose you are given a 4th degree polynomial. As you know, a 4th degree polynomial has how many zeros? 4 zeros maximum. If it has 4 zeros and you are given, suppose 2 zeros, how will you find the remaining 2 zeros? Okay, so that we will discuss today. See, how to find remaining zeros of any degree polynomial when some zeros are given, when sum of its zeros are given. So what does it mean, see children? In order to understand this, let us consider one example in which I will discuss the steps how to find. You see, suppose you are given a polynomial 4th degree, you see x to the power 4. You are given a 4th degree polynomial in variable x, p of x equal to this much, okay? X to the power 4 minus 3x cube minus x square plus 9x minus 6, okay? So this is a 4th degree polynomial. So it will have how many maximum zeros? 4 zeros maximum, okay? Suppose you are given 2 zeros only. Suppose 2 of its zeros are given. One is minus root 3, the other is plus root 3. 2 zeros are already given. So it has how many more zeros? It has 2 more zeros. So how to find those 2 more zeros? Okay. So what are the steps? Let us discuss. Okay. See, let us discuss what are the steps. See children, this is the given polynomial and you are given minus root 3 and plus root 3 are the 2 zeros. Okay. Just we read factor theorem. We have already read factor theorem in class 9. Okay, here factor theorem will come in use. We will use the concept of factor theorem here, okay, to find the remaining zeros. So what is that you see? So you are given minus root 3 and root 3 are zeros. Whose zeros? Zeros of p of x. Okay. So that means the value of x is minus root 3 and the value of x is also plus root 3. Okay. Now see children, in class 9 factor theorem we have read, if x equal to minus root 3 is a zero of this polynomial, if x equal to minus root 3 is a zero of this polynomial p of x, then therefore by factor theorem you apply you see, what was the factor theorem? There were 2 statements in class 9, factor theorem. If p of a, remainder equal to 0, then x minus a is a factor. And if x minus a is a factor, then if x minus a is a factor of the given polynomial p of x, then p of a will be equal to 0. So that concept we will use here, you see. So if x equal to minus root 3, you see, since x equal to minus root 3 is a zero of this polynomial, therefore by factor theorem, what I just told you now, x minus root 3, I said if p of a equal to 0, you see, x minus a is a factor, you see, x minus a is a factor. If p of a, that is the remainder theorem, if p of a equal to 0, then x minus a is a factor of the given polynomial p of x. So if x equal to minus root 3 is a 0, then x minus root 3, that is x plus root 3 is a factor of p of x. Okay, similarly you see, x equal to root 3 is a 0, so therefore x minus root 3 is also a factor, you see, factor of p of x. So what I mean to say children, if x equal to minus root 3 and x equal to root 3 are the 2 zeros of the polynomial p of x, then by factor theorem, x plus root 3, here it is x equal to minus root 3, so it will become x plus root 3. So x plus root 3 will be one factor, and if x equal to root 3 is a 0, then x minus root 3 is another factor of p of x, the given polynomial p of x. That means if x equal to minus root 3 and root 3 are the zeros of the polynomial p of x, then x plus root 3 and x minus root 3 both are what? They are factors of the given polynomial p of x. Okay children, now I am asking one question. Suppose 2 and 3 are factors of 6. Suppose, no, not suppose, it is true. We know that if 2 and 3 are factors of 6, what we write? We write 6 equal to 2 into 3. Now see, if x plus root 3 and x minus root 3 both are factors of p of x, then what we can write? Then we can write, you see, then we can write p of x equal to, therefore, since x plus root 3 and x minus root 3 both are factors of p of x, so p of x will be equal to x plus root 3 into x minus root 3. That means we can write p of x as x plus root 3 into x minus root 3. Okay, that means it will be equal to how much? It will be equal to x square minus 3. That means, you see, if p of x equal to x square minus 3, that means x square minus 3 is a factor, you see, of p of x. You see, children? Okay. So if x equal to root 3 and x equal to minus root 3, both are zeros of the given polynomial, then first you apply Pythagoras, that factor theorem. So x plus root 3 will be a factor of p of x. Again, x minus root 3 will be a factor of p of x. If x plus root 3 and x minus root 3 both are factors of p of x, then their product must be a factor of what? The given polynomial p of x. That I have written here. P of x equal to x plus root 3 into x minus root 3, which is equal to x square minus 3. And this x square minus 3 is definitely a factor of the given polynomial. Okay. Now see, children, what is the next step? The next step is, we got, what we got? We got x square minus 3. We got x square minus 3 is a factor of p of x. Now see, if x square minus 3 is a factor of p of x, then p of x, if divided by x square minus 3, will definitely give you 0 remainder. If x square minus 3 is a factor of the given polynomial p of x, then if you divide p of x by x square minus 3, you will certainly get 0 remainder. So, what is the next step? After this step, what is the next step? You divide p of x, that is x4 minus 3 x cube minus x square plus 9x minus 6 by this factor. It is x square minus 3. Okay, have I written the question correctly or not? Let us see. Yes, x4 minus, yes. So this polynomial, you see, this polynomial as x square minus 3 is a factor of this polynomial. Okay, so if you divide this one by x square minus 3, if you divide p of x by x square minus 3, the remainder will be certainly 0. Let us see how. Okay, this is the next step. So children, try to understand. If two zeros are given, first you apply your factor theorem. Okay, first you got x minus root 3 one factor, then x plus root 3 another factor, because x equal to root 3 1 0 and x equal to minus root 3 another 0. So you got x plus root 3 one factor, x minus root 3 one factor, two factors. Now multiply the two, find the product of the two factors. It is x square minus 3. So x square minus 3 will be definitely a factor of p of x. So as x square minus 3 is a factor of p of x, so p of x dividing p of x by x square minus 3, we will certainly get a 0 remainder. Let us find out. Let us do the division. So divide, you know division, x square, it will be x4 minus 3. This will be minus 3x square. Change the sign. I am changing the sign, you see. This one cancel. This is minus 3x cube. This is minus x square plus 3x square. It will be plus 2x square plus 9x minus 6. Okay. Now minus 3x cube, this will be minus 3x minus 3x cube divided by x square. Yes, x cube by yes, minus 3x. So minus 3x you multiply here, it will be minus 3x cube. Minus 3x you multiply by minus 3, minus plus, it is 9x. You see, plus 9x. Now you change the sign, you see, this one cancel. So what is left? It is 2x square minus 6. Now 2x square divided by x square, it will be plus 2. You see, you know long division, how to divide one polynomial by another in class 8 and 9. Okay, so that I am doing. I am finding the other factor. You see, one factor is x square minus 3 of the given polynomial p of x. So if you divide, you will get 0 remainder and this will become another factor. Okay, now then if you factorize it by splitting the middle term, you will get the other two zeros easily. Okay, so you see. So this is 2x square minus 6. Now you change the sign. You see 0. See, we got 0 remainder. On dividing p of x by one of the factors, that is x square minus 3, we got 0 remainder. Okay, so which proves that this is a factor of this given polynomial, and this is a quotient. This is another factor. Now look at children, the second factor, that is x square minus 3x plus 2, is a quadratic polynomial. So if you split it by middle term, splitting the middle term method, factorization method, you will get the other two zeros. So what is the next step? This is a very big question. It involves so many steps, children, so you have to understand it. There is no other alternative, no other way. So you see, now after finding the second factor, that is x square minus 3x plus 2, which is a quadratic polynomial. Now you split the middle term, factorize it by splitting the middle term in order to get the other two zeros. Okay. So you know how to do by splitting the middle term factorization. It will be x square minus 2x minus x plus 2. Okay. Minus 2x minus x is minus 3x. Now you take common x minus 2, take common minus 1, it is x minus 2. See, it is x minus 2, again you take common, it is x minus 1. You see. Now these are the two linear factors of this quadratic polynomial. Okay. Now how to get the remaining two zeros? You see. Now to get the remaining two zeros, what you will do? You equate this one to 0, this factor, equate this linear factor to 0, and also equate this linear factor to 0. That means x minus 2 equal to 0 and x minus 1 equal to 0. So what will be x? X will be 2 and x will be 1. You see, children? So these are the two remaining zeros. You see, these are the two remaining zeros. The remaining two zeros are 2 and 1. If this is the, you see, if this is the quadratic polynomial, 3x cube, it is x4, x to the power 4, yes. If this is the fourth degree polynomial, and if its two zeros are what? One is root 3 and the other is minus root 3, the remaining two zeros will be 2 and 1. Okay. So see how we found. I think you understood. Once again I am summarizing the steps. Okay. What are the steps? First you are given two zeros, apply factor theorem, you will get two factors. Okay. Now whatever two factors you got, you multiply them, find the product, you will get a single number, single polynomial. Okay. That polynomial is x square minus 3. Okay. So this will also be a factor of what? The given polynomial. So as this is the factor of the given polynomial, so divide the polynomial by this factor. You will get a quadratic polynomial. Now you factorize this quadratic polynomial by splitting the middle term. You will get two linear factors. Okay. So these two linear factors, if you make it equal to 0 or if you equate it to 0, then you will get two values of x. So these two values are nothing but the two other or remaining zeros of the given quadratic polynomial. Okay. So these are the steps, children, how to find the remaining zeros of a polynomial, any degree polynomial, when sum of its zeros are given. Sum of its zeros are given. How to find the remaining zeros. I hope you understood. With this we came. Already division algorithm I have told you. Division algorithm. P of x equal to Q of x into G of x plus R of x, where G of x is the divisor, Q of x is the quotient and R of x is the remainder. You know it, already I have discussed. So with this we came to the end of this chapter, that is polynomial, as given in your CBSE syllabus for class 10. I hope, children, you understood. So we will discuss problems also. This is also one of the problems. This is one problem I discussed. We will discuss more problems in the next class, but we are going to start a new chapter the next time. Okay. I hope you understood, children. Thank you.